So the next topic that we have here is online mode. And the online mode Etherpad is this one. All right. So online mode for Etherpad, for Crowbar, is something that we've heard a significant amount of community feedback. We've seen some really impressive development steps by the SUSE team and what they've been doing. And this has always been one of our objectives for Crowbar. We chose at the start to not do that because we felt we had field experience that we needed to be able to show up on site or in a lab with every component included, that we couldn't count on internet connections. That's still the case. So we'll still have an offline mode. We have accumulated a lot of knowledge. We've gotten a lot of feedback and suggestions on how to accomplish online mode. And now is the time to do it. So let me describe the business case and the use cases for online mode a little bit. The idea here is that we are building living, breathing systems. They need updates, they need changes, they need package refresh, they need to be able to basically have an ongoing life. Today, Crowbar doesn't do that very gracefully because it's right now standalone. By connecting to the internet, we can now bring in packages as we go. That means Crowbar itself can be smaller to set up. You can do it like you would normally do a package install for Crowbar, which is something we've seen SUSE really moving on. You can bring in bar clamps and the dependencies for bar clamps. We identified this as a key requirement for us to do heterogeneous OS, which is another design topic, because we simply can't keep packaging all of the components for all the bar clamps for all of the operating systems into a single unit. It's just not a tenable solution. So online mode lets us get past this. This also enables other things that we've seen a lot of requests for, which is upgrades to Crowbar, upgrades to bar clamps. All of those things require you to be connected to the internet to pull in the latest code. Those themselves open up huge cans of worms that we have other topics for. Online mode is much more limited than that. Our goal is to be able to allow you to get Crowbar connected to the internet and pull down the dependencies and components that are needed for online mode. And Greg can actually talk a little bit about the many different online modes that we've identified for it. But we feel like this is going to make things easier to develop and easier to manage. Anything to add about the background and use cases, Greg?
Yeah, I mean, there's a whole class of problems for kind of online mode. And the first ones we started tackling have to do with packaging, installing, and updating. There's another side set, which is how do I make external services available on an outbound basis? And we'll talk briefly about that. We're still kind of gyrating on that, not because we don't have, I mean, we have ideas, but we're finding that the actual connecting like DNS and NTP and those kind of services to an external source is somewhat dependent upon what the user's environment is. And so we haven't just declared that path yet. And so I'll talk briefly about that as well. The basic set of features that we're starting with are a way to do a Crowbar installation without having to build an ISO. So you can see some of this in the tree already. Victor started a lot of this work. One of the things you can do right now is there's a README in the Crowbar tree that talks about starting with a base, like Ubuntu 12.4 image, and then installing Git, I believe, and then basically pulling the Crowbar repo and running I can't remember the exact, it's like a remote install or net install command. And that will go off and basically build an admin node and Sledgehammer by pulling in the appropriate packages from the internet. This extends also down to the compute node. So for the model we're using here is we're putting a web proxy in place on the admin node, and really it's on the provisioner. And so the idea is that as Crowbar scales and needs to grow, we can move this service around in the cluster as part of the provisioner. It's not directly tied to the admin node. That way you potentially can give the internet access to the provisioner, and its proxy can then go out to the internet. The goal of this was to try and let the rest of the system believe it's actually talking to the internet. So we use and populate the apt repositories, in the case of Red Hat or CentOS, the Yum repositories, from the bar clamps, so that the systems actually think they're off and going and talking to the internet. They actually go through this proxy. The proxy pulls the images to the admin node and then serves them outbound. This works for both the installation of the admin node as well as the downstream stuff. Work's also being done to allow the installation path to use this as well. So if there's an OS that basically has remote repos instead of potentially a CD, as long as the initrd and kernel and base installation method is available, and we're even looking at trying to pull that from remote sources, that can be pulled in, and then we can go through the normal install path through those external sources. This is particularly powerful for like the Ubuntu side, since that's kind of their already deployable model. I think this might also work similarly for SUSE. Red Hat's a little trickier. CentOS can work somewhat this way, but it follows some of the Red Hat models of needing a larger ISO locally. But even some of those things we think we can work around. But the goal of all this is to have this cache. Now, the caching server we've chosen is Polipo, what we're working with right now, since it's very lightweight, it's very easy to configure.
How do you spell that?
P-O-L-I. P-O. There's an L. P-O-L-I-P-O.
Oh, I typed the wrong.
And the idea is it's very small, very lightweight, easy to configure. It has an offline mode. So one of the things that we've been wanting to make sure we enable as a set of features is a way to stage deployments, to give, while we want internet access, we realize that's not great for production. So the idea is we're trying to enable use cases where you could stage these proxies. So you could have a development cluster where you're testing out a new set of fixes and changes, and then making your production system go from offline mode to online mode, but point at the development's proxy. And then you turn it into offline mode such that it doesn't go to the internet to receive anything, but only caches what it has. And that way you can then update your production server without necessarily having just to take the free wild internet, but you could take what your basic thing you vetted against a development test environment, upgrade your production system, and then put that back in offline mode, and now you're kind of updated packages, and then you could control, as Crowbar matures, right, this is an enabling thing, into rolling upgrades, additional control, movement, and all that stuff. This is kind of the first step in that path to a bigger upgrade story. We felt this was the beginning point to get us to the ability to get more data about how we should upgrade things, because upgrade turns out to be a huge problem or a challenge, I guess is a better way to say it. It's not a problem, we have to solve it, depending on what we try and upgrade. So like security fixes that we might contain in a package are fairly straightforward and easy. But as we go forward of doing OS upgrades and bar clamp upgrades and apps deployed in bar clamps, those kind of upgrade paths need more thought. And this is just the start to let us get into a place where we can potentially stage things into place and then start making decisions about what does it mean to upgrade a Nova system. Is there a rolling upgrade path? Is there a migration path? How do you upgrade Ganglia or those kind of things? We realize that that's probably a per application inside of Crowbar story, but this at least enabled us to get code in place so that we can start discussing about how that works. We're investigating to see if we can use this caching mode across the whole systems so that it's not just online mode. So even our OS installation and OS construction and bar clamps, instead of just putting apt repositories, we're looking to see if we could try and maybe put a Colopo cache out there instead of a repo. That way the downstream nodes don't see a difference between online and offline mode. We think that would be very powerful. It makes the coding simpler and more unified. There's still some questions on the RPM Yum side, potentially YAS side as well, of how well those work through caches. But we'll see. That's an area where we'd love to try and get some community feedback on how well that's working and if that's kind of a design for those functions.
So along those lines, is there a way that the community could expect, if they want to take early builds of Crowbar 2, that would be a preferred path for them to get Crowbar 2 in an online mode and start working with it and get feedback for us?
So currently online mode exists in the, okay, thanks. So it's kind of a similar, so it looks like SUSE already has a similar model. That's good to hear. So we can either have them in parallel or have a dual proxy kind of bounce through thing or something.
Mm-hmm. And these, these changes aren't locked. This is early, so we're presenting here so that we can get this feedback, and we're very open to suggestions. So
in the trunk of the tree, there's a lot of the online mode stuff is there. There's a couple of readmes about how to use it. So you can start trying online mode today. Things that aren't there are like the joint cache or any of the Rails or DB work. We're doing that in a separate release tree so that we can keep more of the stable features going into trunk, and the experimental kind of high churn stuff are going into the release Rails 3 and DB is what we're calling it. So you can play with that today. We'd love feedback on how well it works for you. Victor's already put a bunch of the readmes out there, so if you look in the top of the Crowbar tree, you'll see the readmes out there. That's how we can play with it.
How soon do you think it'll be stable enough for? I know there's already some online work being done. The page I've just flashed up, this link to off the Crowbar 2 refactor page, which lets you build some online mode stuff. That's very edge.
That's edge and has a lot of the Rails 3 stuff in it. If you're just trying to do a trunk with the online mode, Victor's been testing that himself somewhat thoroughly across both Red Hat or CentOS and Ubuntu. And so people willing and wanting to try that just to see. It's like 3 or 4 steps to get it started. So I'd recommend going and looking in the Crowbar tree and seeing that README. I think Victor sent a note to the list about it as well already. So the point is that's out there to play with today.
We've said Victor a whole bunch. Victor Lothar is responsible for a lot of the dev integrations, for the dev tool integration, the network integrations, the dev tool work, a lot of our continuous integration work. He documents things very thoroughly, so I highly recommend when he posts a long email to the list with a lot of text and details in it, that it's worth the review to understand the impacts and repercussions. But please ask questions about that to help figure that out. And I would encourage you as we go, if you see something coming up, please feel free to update the Crowbar Wiki. Help us create documentation that makes it easier for you to consume what we've got going. We're putting more investment in that in our team. We've been flagging it out as a team priority to make the Crowbar Wiki easier and more friendly to use, the documentation more friendly to use. But it's worth calling out Victor Lothar's work here and contributions. So. If you have questions, it'll help you to maybe ping out in the list directly and say, Victor, hey, I have a question about continuous integration or some of these pieces. This is really significant capabilities. We've wanted to do this for quite a while. It is a disruptive change to how things get done. and it will not necessarily eliminate the need for the Crowbar YAML metadata. So one of the, I guess as a closing note for this,
there's more to.
Okay, we'll keep talking. One of the things about this is that it's still important that bar clamps identify which packages they need, because we have to be able to identify dependencies.
And the repos. The repos become now the direct path for a lot of these things. So it's interesting. The repos, as we go to online mode, are used to populate who we talk to. The package lists are what we use to determine what should be cached on the ISO so that it will work in isolation or offline mode. Both those are still very valuable pieces of information, because we think offline mode is still valuable from a closed deployment loop. I know that's not everybody's use case, but we think it's a powerful one that we need to maintain. Now, that's at least for initial installation. Once you're up and running, there are times, and we expect internet access to be available. So that's kind of and by internet, we actually mean outbound external internet. There's the other aspect of this feature. It's called online mode, and as one of the SUSE gentlemen have put up here, right, they're talking about how they deal with the DNS forwarding stuff and the discovery. That leads to the other aspect of online mode. Right now, most of the services, things like DNS, NTP, logging, I think those are the main ones currently, all have the ability to specify kind of outbound servers to talk to. And right now, we've relied on that by saying, okay, we're going to push, we're going to say that's on the public network, and we're going to rely on the Nova public network to be the outbound access path. Okay, that may or may not be the case. We may not want to merge that Nova public concept with the actual outbound access path. It may be the case that outbound access is through a natting firewall gateway thing on the admin network, such that the admin node or those three services within the admin node or wherever you put them in your cluster deal with the outbound access, right? All those kind of questions. Right now, the bar clamps can talk to external resources, but we haven't hard-coded or even really described an outbound path other than saying, well, we're just going to put it on the public network. Part of this discussion is around, and this is where we could use we could use community feedback of what do you guys think is a viable set of options for that? And what are you guys seeing in your usage? And what are your expectations? Our goal has always been that the admin network was a non-routable network. It was kind of Crowbar's own network that it could deal with and had its own security controls on. Or at least people weren't accessing it from outside. I think that's a valid deployment use case. The question is, okay, so what should the expectation be for outbound pathing? So those are kind of the questions that we're looking for in that area. We have something, it kind of works, there's ways to do it. I think it's definitely the case that we need to document some of the ways to go about doing it and go from there. Good. So anyway, just that's kind of all we have on that right now. And so
this is the start of the conversation.
Right. So,
we are not trying to present this as a fait accompli, just the opposite. We want to engage in a discussion and a dialogue about it.